You're watching the Intel Network Builders vSummit series. I'm Guy Daniels, Director of Content at TelecomTV. With telco, energy, healthcare, and other critical infrastructure connected to 5G, how well is the industry prepared to deal with cyber threats? How do you mitigate different attack vectors on all 5G layers, from signaling and data to applications and management? For 5G to live up to its promise of transforming industries, companies need the confidence that 5G networks and services have enterprise-grade security today and in the future. Well, joining me now to discuss the security challenges and solutions are Sab Gozel, Segment Director for Enterprise and Cloud Networking, Network Platforms Group at Intel, Chris Caviggioli, Xeon SP Platform and Technology Product Manager at Intel, and Leonid Burakovsky, Senior Director, 5G Product Management at Palo Alto Networks. Hello everyone, good to see you all. Now, there's been a couple of announcements recently from Dish, which is building out its virtualized Open RAN 5G network in the US. It chose Intel's FlexRAN software reference architecture for its deployments, along with its Xeon scalable processor and other solutions to deliver the flexibility and agility it requires. And Dish has also selected Palo Alto Networks to assist with 5G container security, secure network slicing, real-time threat correlation, and dynamic security enforcement. And we heard from Dish during our fireside chat as part of this vSummit. But these announcements really do show how important security is to the latest generation of networks. So, Lenny, let's first talk about the security challenges that we are seeing in telecoms networks today and how these are evolving.
If we believe that 5G is for enterprises, and we are seeing that it's extremely important for enterprises to transform the business, to do digital transformation, and 5G ecosystem is perfect for it. So if we believe that 5G is focusing on enterprises, what is missing here? What is missing that was not in 4G or in 3G? And what is missing is enterprise-grade security. In 3G and 4G, we had very important layer 3, layer 4 access control, denial of service, not. But it's important to have, but it's not enough. It's not enterprise-grade. So for enterprises to really trust 5G ecosystem and enroll in this digital transformation, they need this trust that security is enterprise-grade. And I would love to discuss what enterprise-grade security is. In our view, enterprise-grade security in 5 main buckets. First, it's all layers. It should be visibility and security and prevention on all layers, signaling, data, application, and management. And some of these layers were also taken care in previous generation, and some of them not so much. For example, data layer. Data layer in a lot of cases was not taken care of from security perspective. For example, if you have ransomware, and lately we are seeing spike in ransomware around the globe, definitely here in the US. Ransomware is running inside mobile tunnels on the data layers. If anyone taking care of, if anyone is even seeing the ransomware running inside this mobile tunnel, it's just an example of how important data layer security is. And I can give a lot of examples on all other layers. Signaling, for example, paging storms or authentication storms. A lot of storms and activities and threats are happening also on the signaling layer, roaming interface, GTPC, for example. So this is one, all layers. Second one is all interfaces and all locations. Historically, security was done only on internet perimeter mainly. And it's important to do when attacks are coming from the internet. But what about botnets attacking the network or attacking the service from infected devices? There is no security there. The only security mechanism that is deployed in some network, not even in all networks, it's our IPsec. IPsec will not help in this case between different E0Bs and G0Bs and mobile core. IPsec will, in this case, even hide an attack inside IPsec tunnel and inside mobile tunnels. So all locations should be taken care of. Roaming is a perfect example when something is coming from another country, from another network, and it always should be secured and checked for visibility and preventions on all layers, signaling and data definitely. And we have a lot of examples that I don't have time now to go into, but we can have full hour discussions only on each of these buckets. Number three is automation. Automation is extremely important. Our machines are attacking us, and they're changing how attacks are happening every day in hundreds of thousands new different flavors. It can vary from completely new malware to just some small adjustment on the hash. But machines are changing this every day. So on our side, also machines and machine learning should be checking all day zero attacks and different other kinds of automation. Then, of course, it's all attack vectors. Not only basic denial of service attacks or signaling attacks that is important, but also ransomware and malware and command and control. For example, if we see command and control traffic on mobile network, it means that already some industries, for example, electrical grid or manufacturing, they already have infected devices because command and control traffic is running through the network. Or things like remote code execution or remote command injection or remote information retrieval. All these threats and vulnerabilities vectors should be taken care of. And then all life cycles. This is what is changing right now. It's not only run, where historically we were doing security checks on the runtime, but with software development, we should take this, it's called shift left, OCI CD, continuous integration, continuous development. It first should be done during the software development cycle to find vulnerabilities there. It's called build cycle, then ship to deploy cycle, and only after that to the run. So all these 5 buckets should be taken care of.
Thank you, Lenny. So much to be aware of there. So, Sab, how do network operators and their partners address these security challenges?
Yeah, and so Guy, just iterating some of the concerns Lenny's raising here, and he's characterized those well. We've seen from the news the threat landscape continues to evolve. Lenny mentioned ransomware, for example. That's bigger than news today. Just making reference to one of the sort of the biggest operators in the US just recently experienced a cyber attack in its infrastructure. To give you some details there, a young lad was able to identify an unprotected node. It was a router node, and is able to put together a fairly sophisticated DNS attack and retrieve enterprise credentials or end user credentials. That's a classic example of a real world challenge that our carriers, service providers, and enterprises face. Enterprises are one step ahead in terms of security, and that kind of makes sense because it's their assets that are at stake here, their credentials, their the things that drive their businesses, and they're placing trust in the service providers. 5G holds great promise in its attributes in terms of how it's going to shape the world, but unless the security elements come with it, it's going to be faced with a challenge of winning the enterprise trust, and enterprises are going to be the principal consumer of this technology. With that said, how is Intel going to address some of these challenges? And for the reasons that Lenny's articulated, and certainly the threats that we perceive moving forward and the sophistication of those. For those very reasons, Intel sees innovation and technology innovation in security as one of its key strategic pillars. We continue to build security capabilities, security enabling capabilities in our silicon processors across the board, from our hard iron sort of industrial server sockets all the way down to the low end sort of SoCs that you'll see in small devices. At the heart of all of these are our instruction sets, for example. Just to name a few, but our AES instruction sets are used widely throughout the industry by developers to enable encryption, high-speed encryption. Encryption is the first line of defense these days, and it's actually very refreshing to see how our infrastructures, both from an application and service standpoint, is now taking advantage of encryption as a first line of defense. Just less than a decade ago, that wasn't there. So there's that exponentiality in terms of adoption, which certainly underscores the importance of security, but it's not enough. Um, we have a technology, for example, Intel Quick Assist, which is now getting more and more industry attention and adoption. This provides the capabilities to drive encryption or bulk crypto operations up to 100 gigabits, very nicely suited to sort of the types of infrastructures and bandwidth consumption rates we're talking about in the 5G world. Um, on top of that, I always make the point that encryption is as good as the keys that enable it. Keys are basically assets that the enterprise will own, and that's how they drive the encryption capabilities. But if those keys are compromised, then that encryption is pretty much, table stakes in terms of providing protection. And so, with that said, Intel recent generation processors named Ice Lake actually has a capability that's very unique in the industry called software guard extensions, or SGX in its acronym. And this is a technique that vendors, Palo Alto and others, can take advantage of in terms of creating security enclaves in memory, and it's such that that memory can be used to store keys in a manner that's very secure. And thereby, enterprises can basically build trust that the encryption that they're rolling out or consuming is rock solid. But again, it's still not good enough. You've got to go above and beyond. We've come from a world where security has always been a reaction to an attack. The attack has always happened. Then you quarantine and you apply you quarantine the and isolate the attack. You then apply forensics to determine what happened. But the damage has already been done, which is why the world of artificial intelligence, where you do take advantage of advanced techniques like machine learning and deep learning to make security more predictive, comes into play. Ultimately, what we're looking at in the industry is a world where we have to be one step ahead of the cyber attackers, such that we can identify, mitigate, and protect the infrastructure from threats that are about to happen as opposed to has happened.
Great, thank you for that, Sab. Well, as we mentioned earlier, Dish selected Palo Alto Networks as its security vendor. So, Lenny, what did Palo Alto have that secured that deal?
Dish published very good, very nice white paper. So we will share the link for this white paper. And in this white paper, Dish mentioned concept of all layers, all location that I already emphasized before. Dish also mentioned very important concept of correlation. In mobile networks, IP is changing all the time. So what is constant? Constant is your SIM card, your identity. And constant is your equipment identity. So user and equipment identity. This correlation is very important in order to understand specific malware or ransomware or command and control, what real user ID and what real equipment hardware ID it's infecting. We are doing this correlation automatically. It's important in correlation and it's important of automation, because otherwise it's extremely difficult to do this correlation manually. Also, Dish is mentioning a very important concept of security per slice. This is fundamental difference between 4G and 5G. By far the most important technological difference. In 5G, for the first time, you can do end-to-end quality of service, end-to-end bandwidth. What we are adding here as Palo Alto Networks, we are adding the concept of per slice security. So now it's possible in the real time detect what slice is, and slice identification is running on the signaling layer. This is where the most important intelligence is running in mobile network. So we can dynamically extract slice information and dynamically real time do different security policies per different slice, which is fundamentally different from 4G. You can't do this in 4G dynamically end to end. So, for example, it can be the highest security slices for really critical infrastructure or power grid, where it can be provided highest level of security, absolutely everything, threat preventions, or day zero detect, or DNS security. All security elements can be put it in this slide dynamically. In other slices, it can be parts of the security. In some slices, it can be basic layer 3, layer 4 access control and denial of service security. So this is very, very important concept that Dish is emphasizing in their white paper.
Okay, thank you, Lenny. Well, Chris, let me now turn to you and open up the conversation a little. What is the role of standards and industry organizations in 5G security?
That's a great question. And there, as it was mentioned earlier, the network AI is an area that there's a lot of innovation going on right now. Intel is involved in practically all of these various groups across Linux Foundation, 3GPP, IETF, GSMA, ITU, a whole bunch of acronyms, MEF, TMF, and also the European Telecom Standards Institute, or ETSI. And I'm personally involved in the ETSI E&I, or Experiential Networked Intelligence Group. And what they're doing is they're putting together a reference architecture for cognitive network management using AI, ML, big data analytics, and such to do things like collecting and sifting through data telemetry of what's actually happening in the network and to make smart decisions based on that in a closed loop kind of automation. Intel is also involved in ETSI SAI, which stands for Securing Artificial Intelligence, and exactly looking at when artificial intelligence is processing that somebody isn't getting in there to disrupt that. And in one of the sessions today, we'll also talk with Palo Alto Networks is involved with us and with a handful of other companies in the 5G cybersecurity project within the National Cybersecurity Center of Excellence that is funded by the NIST, or the National Institute of Standards and Technology, where a lab is being set up and a notional architecture is proposed. It's going to be vetted, and there'll be something written about how, using with experience, how to keep a 5G network safe from external attack. And Intel's involved in the Confidential Computing Consortium. That's where SGX has also been helping us a lot. IETF, DMTF, Trusted Computing Group. There's a whole bunch, and we're doing this so that we stay ahead of the curve. We know what's happening, and we do it together as an industry using standard methods.
Great. And Lenny, do you also actively participate in these fora and associations that Chris has outlined, and that which obviously play a major role in security?
Yes, thank you. So in addition to what Chris absolutely rightly mentioned, we are partnering together in NIST. I would like to add two other standards and industry forums, GSMA and Open RAN. I am personally involved in both of them. GSMA is extremely active and very important from security perspective for mobile industry. So I'm working with GSMA, and we created for the first time data layer security reference document. It's FS37. And in this document, it's very detailed technical document. I am really encouraging our audience to take a look at this FS37. In a lot of details, we are describing what can be done and what should be done on the data layer inside mobile tunnels from security perspective. So you will see here how we are proposing to detect attacks running inside out and outside in on different layers inside this mobile data tunnel. So I believe that GSMA is doing extremely good job. Of course, on the signaling layer, GSMA historically was very good in different reference documents on different signaling layers, diameter and SS7 and GTPC, and now more and more on the data layer. With Open RAN Policy Coalition, we created 5G security white paper back in April. It's once again public. This is public white paper. It's the same way as Dish is public white paper. In the case of Open RAN Policy Coalition, I work together with colleagues from a lot of companies that are part of Open RAN Policy Coalitions, and we created very detailed, functional-wise, conceptual-wise document where very similar concept as I described today. The security should be done on all layers, all locations, all attack vectors, automation, slicing security. very conceptually important document already done by Open RAN Policy Coalition. So these two I would add to what Chris absolutely rightly described, and NIST, we are partnering together.
Okay, thank you. Now, if we take a closer look at the silicon, Chris, what is Intel working on in the chip space as the security threats keep evolving over time?
Yeah, so in April this year, we launched our third generation Intel Xeon scalable processor. That highlighted a lot of security things that were in that particular platform that were new for that platform, but not new in the industry, that we've actually deployed in the industry already before. We've just integrated them into the third generation Intel Xeon scalable processor. One example is the Intel Software Guard Extensions, or SGX, as Saab was mentioning. That's been in the industry, it's been battle proven for years in the PC and in the cloud enterprise parts of our business. It reduces attack surface. Essentially what SGX does is it ensures that a valid program is running on valid hardware with valid software. And we've joined the Confidential Computing Consortium, which is an umbrella project of Linux Foundation, to make that more public and out there. So that was in April this year, the third generation scalable processor. For many years, we've already been shipping also Intel Quick Assist technology that Saab had mentioned as an external hardware accelerator for cryptography and also for lossless data compression. And what we announced in August, just a few weeks ago at Hot Chips and the Intel Architecture Day, is that this Quick Assist technology is now in its fourth generation hardware engine, number one. And number two, that hardware engine is being integrated into next generation Intel scalable processor, codenamed Sapphire Rapids. So that's very exciting because that will give us a big boost in performance, both for encryption, decryption, as well as lossless data compression. And in the NIST work that we're doing, where we're setting up a lab outside of Washington, D.C., for testing this architecture we talked about, that will be using our third generation Intel Xeon scalable processor in the infrastructure. And there we will be using the converged boot guard with Intel Trusted Execution Technology, or TXT. It checks when a system boots about the platform integrity to make sure that the platform hasn't been tampered with. And so that will be important. Going forward, we'll look into rolling in some of the other security things that are available and evolving into that lab and into that reference architecture as well. So we're really excited about this because this is a common problem in the industry. We're solving it together with the whole vendor chain and with end users, various service providers that are part of this. So the whole ecosystem working together for a common vision and a common result.
And Saab, let me turn back to you for final comments on this.
Yeah, Chris and Guy, we've talked significantly about sort of security and the chip business as it relates to Intel, but also to pivot that to the software world, right? Where the industry perceives Intel as a silicon processor company, which we are. But what people might not be aware of is we're also investing heavily in software. We actually are one of the more sort of formidable software companies around the world. And a lot of those investments are actually in open software, or opening up the industry, allowing developers to basically write applications and take advantage of some of the optimizations and libraries we bring to bear. For example, DPDK, I want to explain the acronym because it's well known, it's broad market, used in the automation business across the span. It's fundamentally a data acceleration or packet processing acceleration library that most vendors and ISVs use in the world today. We've talked about Quick Assist significantly, but one area as we shift to the cloud, as workloads shift to the cloud, one critical piece of the workload is packet inspection, or should I say layer 7 or application oriented packet inspection. And to that effect, we have a technology called Hyperscan. It's open source, and it's certainly becoming prevalent in the cloud world and is used in most firewalls around the world, essentially to allow inspection of data to become more sophisticated and more responsive. And then, I wanted to underscore the importance of artificial intelligence, this notion that as we combat sort of the oncoming sophistication of threats, being predictive becomes ever so important, or the term used these days is advanced threat management capabilities. But from an Intel standpoint, in our latest generation processors, we have an instruction set called vector neural networks, or VNNI for short, which is essentially new innovation that is now available in silicon, in next generation silicon, to drive machine learning, deep learning type workloads, and especially centered around threat management, for example. With that said, that's just one instruction set. On the software side of the world, we have optimizations around open industry tools and frameworks like TensorFlow. TensorFlow is used in the analytics world throughout the industry. But to get the most out of it, you need to get the optimization. So it's tied to the compute, for example. Open tools for basically optimizing machine learning, deep learning models. Intel brings a tool called the Intel Neural Compressor that's proving very valuable in the developer community to basically become more sophisticated in this area. So our agenda is really to not only allow vendors to build best-in-class security for enterprise grade security, but also in this transformation to the cloud. In terms of threats we can foresee, as we're going to continue to better the capabilities around threat management. But then we have the challenge that once the world becomes cloudified, and certainly coming back to the Dish reference, everyone's probably seen that the fact that Dish itself is collaborating with AWS. And so there's a cloudification dynamic there. What happens in the cloud is there's this abstraction from software from the hardware, right? This notion that containers can be initiated on the fly to transport a particular application or a service to its endpoint. And then as soon as that task is completed, that container is torn down. That's a pretty sophisticated software pipeline. Now, it's great in the sense that it lends itself really well to efficiencies, scale, and the distribution of resources. But at the same time, a software-oriented workflow that's complex in nature as that also creates significant vulnerabilities. Every single termination point in that workflow example, for example, is a vulnerability where an attacker, a cyber attacker, could basically penetrate the network. So this is where these technologies and the framework of tools and the open industry innovation around developers and what they bring to bear is the only way we're going to basically tackle the problem as we move forward in harmony.
That's good to hear. Sab, thank you very much for that. We need to draw our discussion to a close now. Thank you all for participating and sharing your comments and views. Much appreciated. And don't forget to watch the other programs in this Intel Network Builders vSummit series. We have a fireside chat with Intel and Dish, plus a panel focused on the work being done by the National Cybersecurity Centre of Excellence on 5G security. And as well as security, the vSummit series also takes a detailed look at vRAN, Edge, and the network core. For now, though, thanks for watching and goodbye.